Recording now. Here we go. So this is lesson 2.2, day 3, last day. Scatter plots, time series charts. We're going to do one example of each, and then I'm going to give you time to work on those. I think I already gave you 6 problems, right? Yeah. We also need to count up I'm winter signs, so don't let me forget about that today. Okay. Scatter plots. Scatter plots definitely have to be done on graph paper, and the reason for that is because they compare two different variables to see if they are related. Something called correlation and causation. Anybody hear those words before? Correlation and causation? What do they mean? Anybody know? Go ahead, Caitlin.
Cause is like what actually causes it. Correlation is just it's kind of related, but it doesn't cause it.
Yeah, so correlation means that they're both trending in the same way. And anything that is caused by another thing is correlated, but correlation could also be like a coincidence. And so sometimes it is a coincidence. And you have to realize that. There was one study or something, and it was about the amount of pirates in the world, like pirating, and that's like a real thing. Like people not like yar with, swashbuckling, but, like taking over ships and stealing things from people. And the amount of pirating that was happening compared to, the global temperatures. And it was exact. Like, they were moving in exactly the same way. Nothing to do with each other. Just happened to be that way. And there's been a few cases like that where you have things that are correlated that are not necessarily causated. So, and sometimes they're not correlated at all. So what we're going to do today is we're going to talk about shoe size versus, we're going to go, we'll just say middle finger. It's the base of your hand to your middle finger, but anyway. Okay, now first I have to get all of my data. So you're going to want to list this on your paper. I'm going to list this on a separate piece of paper just so that I don't get in the way of my own graph. You can list it on the bottom if you want to. The time series chart you're also going to want on graph paper. So I would leave a little bit of graph paper for that time series chart. I'll also leave this up here so that you can look up when we're doing it, okay? All right, so when we're doing this, I want your hand first, hand, and then your foot. Everybody understand? Because I'm getting data from you, okay? All right, here we go. Nolan. 22, 31. I'm writing it like a point, like an XY point. Cole? 1929. We're going to be graphing all of these. 19 and a half, 30. 17.5, 29.
19.5, 34.
19.5, 34.
18
Okay.
and 30.
1628.
Mm-hmm.
1729. 1929.
Mm-hmm.
19.5, 32.5.
19.5,
Yeah,
32.5.
correct.
Okay.
19 and a half and 30.
18 and what?
And 33.
Okay. Dayton.
19 and 30.
17 and 27.
27 and a half.
Yeah.
Tyler.
18 and 32.
Okay. So we've got 16 people here. That makes sense. So we're saying Anton. So what we're going to do is we're going to graph these. Now, what I'm going to do is I'm going to leave these numbers up, except for right now, where I'm just going to graph the first point, kind of show you where we're going, and then we're all going to do it together. That make sense? Okay. So 2231 is the first thing we're graphing. So we're gonna go hand and foot. Ooh, we did it backwards, didn't we? Because I wrote shoe size down here for my X. And middle finger over here for my right. Are we capable of switching these in our heads? Or should we switch the labels? Okay, let's switch the labels. This is middle finger, and this is shoe size. Now, it doesn't make sense to start at 0 for these, because what is our smallest middle finger length? 16, and our highest?
22.
Okay, so I'm gonna make a jump. Remember, you do it like that, you kind of, it's like a heartbeat, it goes above and below it a little bit. All right, I'm gonna say, let's see, 16, 17, 18, 19, 20. Okay, so I'm gonna start 1, 2, 3 here. And I'll say that this is 16. That this one is, maybe I'm gonna go 4. So every 2, that's 16 and a half. This one's 17. 17 and a half, 18, 18 and a half. $16 to $22. What would it look like if I had started at 0? What do you think my graph would look like? Right, where all my dots would be tiny and clustered all in one spot and it'd be hard to even tell a pattern. So that's why it's important to spread it out and have it from the smallest to the largest. What's our smallest shoe size? 26? Largest is 34. Okay, well these ones we don't have halvesies. Again, I'm doing a broken axis, so it looks like that. It's kind of like you gotta just twist your hand and do the same thing where you go up, down, and over. And then I'm gonna start at 26. Skipping 2, 27, 28, 29, etc. Something that I saw when I was walking around looking at your graphs is I saw that some of you were just putting in the numbers that you got, like, let's say it was like an ogive. That person would just write the numbers that were in like the frequency distribution, you know what I mean? Like the answers for each category, instead of spacing it out. It needs to be spaced out and then you plot the points in afterwards. So it's not always a straight line, and that's okay. All right, so my first one is 2231. 22. $19.29. You guys get where I'm going with this? Cool, so what I'm gonna do right now is I'm gonna put up all of the data points just in case you didn't write them down. And I'm going to work on mine over here.